On the other side, if you go further, you are limited, then your range becomes smaller. And actually this diamond, geometrical diamond shape that you see here, defines the viewing range and the viewing freedom. The freedom is between the two arrows here, and the viewing range is from here to here. I think the chart explains it graphically. Now, some instrumentation, LDIM developed their camera VC Master. This was the first prototype, and the resolution was 0.003 angular resolution, which is very nice. They published a paper that combined with Nokia Group. They got some samples of displays. And what you see is when you use the camera, the conoscopic camera, you get these stripes. And the stripes are the equivalent, no, I don't have it here, it's earlier, the equivalent of this. So a cross-section in the stripes is equivalent to taking the photometer and scanning angular scan. If you tell me, I can reference you to a paper that they published, a few papers actually. Now, just one slide or two slides about the light field. Light field is very similar to multi-view, except that in multi-view you focus these specific pixels to the right eye, and the left eye gets a focus of other pixels, and that's what generates the separation of two images. And in the light field concept, what you do is you make sure that the pixels are in the rear focus of these lenslets, and you get actually parallel beams. Now you have to make sure that the pixels that are here separated by the distance between the two eyes. But then you are not so restricted to the distance because the beams are parallel. And all the time you get the same pixels. The same pixels will appear either here or here or here as a picture. So wherever your pair of eyes move here, you will get a pair of images. But you have to make sure that you don't get reverse. Meaning, you want to see with your right eye this beam and with the left eye this one, but you don't want to put your right eye here and the left eye here because you get a reverse of the image. So as you move across there, you get many pairs that are non-inverting. And in principle, you almost get a continuous of the images except for locations where it's inverted. Now, the people from Toshiba who are developing this and are part of our team, they wrote a procedure how to measure, and what they think is most important besides everything you do for multi-view is to measure the resolution. Because the resolution defines how many views, continuous views you have as you move left and right. And they propose to use a very high resolution camera close to the normal view and use the resolution pattern on the screen, which is like stripes or sinusoidal cross-section. And you analyze this and you actually calculate the modulation transfer function, and from this you calculate the resolution of the system as a total. If the camera resolution is very high, then you get actually the modulation transfer function does not include the camera MTF in the calculation. It can be negligible. This is a little more complex, and they wrote the procedure, I guess, translated from Japanese to English very poorly. And I know from my own experience when I translate from Hebrew to English, not always I am understood. But now we are trying to fix this procedure so it will be well understood to the layman or to people with our background but need to understand what to do.